Water, it's the essence of life, the most vital resource on our planet. It's everywhere on our big blue planet. Covering about 71% of the Earth's surface, water is a fundamental part of our world. We drink it to stay hydrated, swim in it for fun and exercise, and use it to grow our food, ensuring we have enough to eat. But here's the thing. Our water isn't always as clean as it should be. Pollution is a major issue affecting water quality worldwide. Yucky stuff like dyes and chemicals can pollute our water, making it unsafe for drinking and harmful to the environment. These pollutants can come from various sources, including industrial waste and agricultural runoff. One big culprit is a dye called methyl orange. This synthetic dye is commonly used in textile and paper industries. It's used in factories, and if it ends up in our water, it can be toxic. Methyl orange can cause serious health issues and disrupt aquatic ecosystems. That's why we need to find ways to clean up these pollutants and keep our water safe. Environmental cleanup efforts are crucial, and scientists are constantly searching for innovative solutions. And guess what? Tiny superheroes called nanoparticles might be the answer. These minuscule particles have unique properties that make them effective at removing contaminants. These nanoparticles are so small, you need a super-powered microscope to see them. Despite their tiny size, they pack a powerful punch when it comes to cleaning up pollutants. But don't let their size fool you. They are mighty cleaners. Nanoparticles can interact with pollutants at a molecular level, breaking them down and neutralizing their harmful effects. In this adventure, we'll explore how zinc oxide, ZNO, nanoparticles, powered by the sun, can help us remove harmful dyes like methyl orange from our precious water. Ready to dive in? Join us as we uncover the science behind these incredible tiny heroes and their potential to revolutionize water purification. Imagine shrinking yourself down to the size of a grain of sand, even smaller. That's the world of nanoparticles. They're about 10,000 times smaller than the width of a human hair. Now, these nanoparticles aren't just tiny, they're powerful. Because of their small size, they have a lot of surface area. Think of it like this. A crumbled up piece of paper has more surface area than a flat one, right? This means nanoparticles can interact with things around them in a big way. So how do we make these mighty ZNO nanoparticles? It's like following a special recipe. We start with simple ingredients like zinc salts. These salts are dissolved in water, kind of like when you mix sugar in your lemonade. Then we add another special ingredient that reacts with the zinc salts. This reaction creates tiny ZNO nanoparticles. It's like magic, but instead of spells, we use science. Now, here's where the real action begins. When we shine ultraviolet UV light from the sun on these ZNO nanoparticles, something amazing happens. The UV light gives the ZNO nanoparticles a boost of energy, making them super reactive. They create electron hole pairs. Think of it like this. The light gives an electron in the ZNO a push, making a hole where the electron used to be. These excited electrons and holes are like tiny cleaning agents. They react with water and oxygen to create reactive oxygen species, ROS. These ROs are like tiny Pac-Men that gobble up the harmful dye molecules, breaking them down into harmless substances. Section 5. Finding the perfect recipe. Optimizing for the best results. Just like baking a cake, getting the best results with ZNO nanoparticles means finding the perfect recipe. We call this optimization. It's a process where we tweak and adjust various factors to achieve the most effective outcome. We can change things like the amount of ZNO nanoparticles. This is similar to adjusting the amount of flour or sugar in a cake recipe to get the desired texture and taste. Just like adding too much sugar can ruin a cake, using too many nanoparticles can be wasteful. It can also lead to unwanted side effects, making the solution less effective. The intensity of UV light, more sunlight, usually means faster cleaning. This is because UV light activates the nanoparticles, helping them break down contaminants more quickly. The pH of the water. This is like the acidity of the water. The pH level can influence how well the nanoparticles work. Some pH levels work better than others. For instance, a slightly acidic or neutral pH might be ideal for the nanoparticles to function optimally. By experimenting and finding the best combination, we can make sure the ZNO nanoparticles are working at their best to clean the water quickly and efficiently. This involves a lot of trial and error, but the end result is a highly effective water purification process that can be used in various applications. Section 6. Putting it to the test. A simple experiment. To see how well our ZNO nanoparticles work, we can do a simple experiment. First, get 2 containers of water. We'll add that pesky methyl orange dye to both. Next, add ZNO nanoparticles to 1 container. This will be our test container. Then place both containers under a UV lamp. This simulates sunlight. Finally, watch and wait. Over time, we'll see the water in the test container become clearer as the ZNO nanoparticles break down the dye. This experiment shows us the amazing cleaning power of ZNO nanoparticles in action. Section 7. ZNO. Nanoparticles in action, real-world applications. Let's dive into how these tiny particles are making a big impact. So, how can we use this amazing technology in the real world? The applications are vast and incredibly promising. ZNO nanoparticles have the potential to clean industrial wastewater. This is crucial as industrial processes often release harmful substances into our water systems. Factories can use this technology to remove harmful dyes and chemicals before the water is released back into the environment. This not only helps in meeting regulatory standards, but also protects aquatic life. They can also purify drinking water. Imagine having a simple yet effective way to ensure that the water you drink is free from contaminants. In areas where clean water is scarce, ZNO nanoparticles could be used to make contaminated water safe to drink. This could be a game changer for remote communities. Moreover, they can clean up oil spills. Oil spills are devastating to marine life and ecosystems, and having an efficient cleanup method is essential. ZNO nanoparticles can even help break down oil, making them useful in cleaning up oil spills and protecting our oceans. This technology could significantly reduce the environmental impact of such disasters. These are just a few examples of how ZNO nanoparticles can be used to address real-world water pollution problems. The potential applications are numerous, and ongoing research continues to uncover new possibilities. Section 8. A cleaner future. The benefits of using ZNO nanoparticles. Using ZNO nanoparticles to clean water comes with many benefits. Firstly, they are environmentally friendly. Unlike some harsh chemicals, ZNO nanoparticles break down pollutants without creating more harmful byproducts. Secondly, they are cost-effective. Sunlight is free, making this a more affordable solution than other methods. And lastly, they are sustainable. ZNO is a readily available material, making this a sustainable solution for the future. By using this technology, we can move towards a cleaner and healthier planet for everyone. Section 9. Beyond the lab. ZNO and the bigger picture. The use of ZNO nanoparticles for water purification is just one example of the exciting world of nanotechnology. Scientists are exploring the use of nanoparticles for a wide range of applications, from medicine to electronics. As we continue to unlock the potential of nanomaterials like ZNO, we can look forward to a future with cleaner water, improved healthcare, and innovative technologies. Section 10. Challenges and considerations navigating the nano world. While the future of ZNO nanoparticles is bright, it's important to remember that with great power comes great responsibility. There are still some challenges and considerations. For instance, we need to make sure that using ZNO nanoparticles in the environment doesn't have any unintended negative consequences. Safety is another concern. Scientists are working to develop safe ways to produce and use these nanoparticles. And while using sunlight is cost-effective, the initial investment in this technology can be high. By carefully researching and addressing these challenges, we can ensure that we use this powerful technology responsibly for the benefit of everyone. Section 11. Conclusion. A drop of hope for cleaner water. Water is essential for life, and keeping it clean is crucial for our health and the health of our planet. ZNO nanoparticles offer a promising solution to combat water pollution, especially from harmful dyes like methyl orange. By harnessing the power of the sun and the unique properties of these tiny particles, we can break down pollutants and make our water cleaner and safer for everyone. As we continue to explore the potential of nanotechnology, we can look forward to a brighter and cleaner future for generations to come. Remember, Every drop counts.